The goal of this lecture is to understand how to use significant figures when we're performing calculations. And so let's start off with a problem that we can talk through. So if we're given this problem where in our lab we measure 15.39 milliliters of water, and we're measuring using a burette, and we add that to 25 milliliters of water measured in a beaker. So the question then is, what is the total volume of water in the beaker? And at first this question seems pretty straightforward. We're combining 25 mils with 15.39 milliliters. And so what we might first go off is just say, well, 15.39 plus 25 milliliters is equal to 40.39 milliliters. And mathematically this is correct, but what we're going to start to think about is the uncertainty or the error in these measurements. And when we think about what these numbers really mean, this measurement of 15.39 milliliters, the fact that it has a decimal and then 2 spots after the decimal, this is really saying this is 15.39 plus or minus 0.01. So this might be 15.38, it might be 15.40, right? But that's the level of precision we know that measurement. The 25 mils, without a decimal point after it, this is really saying we have 25 mils, but that could be 24 mils or it could be 26 mils. It's somewhere in between there. So this is plus or minus 1 mil. So when we come to our final answer, if this 25 mil measurement is somewhere between 24 and 26 mils, can we really say with certainty that we have 40.39 milliliters? Right? We can only report our answer to the uncertainty of our least certain measurement. And so when we think about this, the way we're going to have to learn to report this is this answer is only going to be 40 milliliters with the decimal point to signify the two significant figures, right? Because we had plus or minus 1 mil on this measurement, our final answer has to be plus or minus 1 milliliter. And that helps us to start to understand our uncertainty in measurements, but we can kind of look at some rules to help ourselves. And there's 2 rules we need to know. The first is, how do you deal with significant figures in a calculation if we're undergoing an addition or a subtraction? And the rule is, your final answer can't have more significant figures to the right of the decimal than any of the original numbers, right? And that's what we just looked at. So for another example, if we take 523.18 grams and we were to add to that 0.01315 grams, we can say, what is our final answer? So we can easily punch this into our calculator to get the number, but when we think of the uncertainty, we're going to look at the number of decimal places. Here we have 2 decimal places, and here we have 1, 2, 3, 4, 5 decimal places. So our rule says we can't have more sig figs to the right of the decimal than any of the original numbers. And so we only have 2 here, and so our final answer can only have 2 decimal places. And so we're going to have to report this to only 2 decimal places. Our second rule is dealing with multiplication and division. And this is probably the one we'll see more often. And this one is simply, your final answer cannot have more significant figures than any of the original numbers. So this is just counting total number of significant figures, not worrying about where a decimal may be. And so when we look at this one, we can say, what is the density of a block of copper with a mass of 160 grams and a volume of 8.49 milliliters? And here, if we recall, density is mass divided by volume. And so to solve this, we would take our mass and divide by the volume. And the question for this problem is, how many significant figures do we report our answer? The multiplication and division rule says we can't have more sig figs than any of the original numbers. And so we say the 160 is 2 sig figs, and the 8.94 is 3 sig figs. And so because 2 is less than 3, our final answer can't have more than 2 significant figures. And so we're going to report our final answer to 18 grams per mil. And we would have to round to that 2 significant figures. So I hope that helps thinking about sig figs when you go through calculations. Thank you.